Okay, so this is our operations with rational expressions continued. So today we did simplification, we did multiplication, we did division, and finding our restrictions. So now we're moving on to adding and subtracting. So this note is in your Google Class. You can just print this out, or you can write it out if you want to open it in Google Class. So adding and subtracting, we're going to factor the numerator and the denominator. We're going to find the lowest common denominator using the factors of each expression. And we're going to add or subtract the numerators, expand and collect like terms. Then we're going to simplify the resulting expression and state the restrictions. So this is exactly the same as if we were going to add or subtract any other set of fractions. So the first example, I have 3 over x squared minus 4 plus 5 over x plus 2. So the thing to keep in mind when you're adding any fractions is you have to have the same denominator. Then you keep the denominator and you add across the top. So because we don't have the same denominator, that has to be our priority. Otherwise, we can't do anything. So we're going to factor out the bottoms. So this equals 3 over x minus the square root of 4, which is 2, x plus the square root of 4, which is 2, plus 5 over x plus 2. This shows up twice, so we're not interested in that. You're only interested in things that are different from one term to the other. So this x minus 2 is what's interesting to us. So we're going to take 3, keep that, x minus 2, x plus 2, plus 5, and we're going to multiply it by the factor in the denominator that we don't have. So 5 minus 2 over x plus 2, x minus 2. So we do this because x minus 2 over x minus 2 is a special form of 1. So we're not changing the fraction, we're just making it a little larger. So that's to say 3 over 3 is equal to 6 over 6. We haven't changed anything when we multiply 3 by 2, so long as we do the same thing to the top as we do to the bottom. It's because 3 over 3 reduces to 1 and 6 over 6 reduces to 1. So if I were to take 6 over 6 and multiply it by 2 over 2, then I would get 12 over 12. And again, I haven't really changed anything, just changed how it looks. So because we have this here, it could cancel off and just give us a special form of 1. But in order to do an addition, we need the same denominator in both terms, and then we add across the top. So this then equals 3 plus, and we're going to FOIL this out, so 5 times x is 5x, 5 times negative 2 minus 10. So that's the addition across the top, keeping the bottom. Right, so same bottoms, so just keep that, add across the top. And then this equals, well, we can simplify some things here, the 3 and the 10. So we get 5x minus 7, so negative 10 plus 3. Keeping our bottom, x minus 2, x plus 2. And now my restrictions, when I look all the way through here, all we have is x plus 2, x minus 2 in the bottoms. So my restrictions are x cannot equal plus or minus 2. Our second example is x plus 1 over x squared plus 2x minus 3 minus x plus 2 over x squared plus 4x minus 5. So same thing, we're going to FOIL this out, or sorry, not FOIL it out, we're going to factor this out and factor this out. So we have x plus 1 minus x plus 2, and let's see what those are over. So I need two numbers that multiply together to give me -3 and add together to give me 2. So x plus 3, x minus 1. And if I FOIL that out, I get x times x is x squared minus x plus 3x, which is 2x minus 3. So that's good. And we do the same thing here. So two numbers that multiply together to give me -5, add together to give me 4. So x plus 5, x minus 1. 5 times -1 is -5. 5 minus 1 is 4. So we're good to go there. Now we're interested in things that are different. This shows up twice, so I don't need to worry about it. This is different from this term to this term, and this is different from this term to this term. So my next step is to cross multiply. So I go to x plus 1 times x plus 5. Whatever I do to the top, I have to do to the bottom, so I don't change anything. X minus 1, x plus 5, minus x plus 2. It's different for him, is this term, so we're going to multiply that. And we're going to do it on both the top and the bottom. Order doesn't matter in multiplication, so stick it in wherever you want. Okay, so now I have the same denominator because all these factors show up in both terms. So I can just keep my denominator and I can add across the top to make my life a little easier, though I'm going to FOIL this stuff out to see if there's anything I can reduce. So I'm going to take x times x, x squared, plus 5x, plus x, plus 5, minus x times x is x squared. Because this is a negative, everything will be negative. So x times 3 is minus 3x, minus 2x, minus 6. Because we have a bunch of positives and a bunch of negatives, some things are going to work out for us. This will go away, this will go away. Keeping my denominator. Okay, so now we have 5 plus 1 minus 3 minus 2. Well, 3 and 2 add together to 5, so I have -5 and +5. Those also go away. So I am left with this x. So x, and then plus 5 minus 6 minus 1. So that whole top reduces down to x minus 1, which is one of our factors on the bottom, so that's good too. X plus 3, x minus 1, x plus 5. So before I simplify, I want to state my restrictions. So my restrictions are x cannot equal +1, -3, or -5, right? Because if x is equal to -3 plus 3 is 0, which gives me a 0 denominator, which is an error. It's an irrational thing to do, so it's not a rational function. 1 minus 1 would be also 0, so it can't be 0. And -5 plus 5 would be 0, so it can't be that either. All right, so now we can, now that we've stated our restrictions, we can move on to factoring, or crossing off any like factors that show up in the numerator and the denominator. So this thing reduces to 1 over x plus 5, x plus 3.